The question asks about two acids and their reaction with copper. We are asked why dilute hydrochloric acid and copper do not react, and whether dilute nitric acid and copper will react or not, and we need to explain each answer in terms of oxidizing or reducing agent strength. The table of reduction potentials lists many reduction half reactions from left to right, and their reduction potentials. Here we have shown just 3 half reactions needed for the 2 questions in this video. Reduction potential is the measure of the tendency of an electrode to gain electrons and undergo reduction. The more positive the reduction potential, the more likely the species is to be reduced and gain electrons. And the less positive the value, the more likely that element is to be oxidized. In other words, if we take 2 reactions, the one with the more positive electrode potential is more likely to go in this direction, which is reduction, compared to a reaction below it, which is more likely to go in this direction, which is oxidation. So species to the top left are stronger oxidizing agents than the bottom left, as they are more likely to undergo reduction and gain electrons from another species, and thereby oxidize the other species. And species to the bottom right have a greater tendency to lose electrons and be oxidized, and thereby reduce another species. We can say an element which is a stronger reducing agent will reduce an element that is a weaker reducing agent. So, when dilute hydrochloric acid, which contains hydrogen ions, and copper are put together, no reaction will occur. This is because copper is a weaker reducing agent than hydrogen, and so cannot reduce hydrogen ions to hydrogen gas. And when nitric acid, which contains nitrate ions, is mixed with copper metal, because the nitrate ions are a stronger oxidizing agent than the copper 2+ ions, the nitrate ions in the acid will oxidize copper metal to copper ions. So yes, a reaction does occur with nitric acid and copper.